Hi there, how you doing? Today I want to talk to you about a different parent graph, specifically rational. It is based off the mother function y equals 1 over x. Here's our graphing form of it. Just like everything else that we've been doing with parent graphs so far, it is opposite, same, and that will give you the center. Through the center, we will draw our asymptotes, vertical and horizontal. If A is positive, our graph will look something like that and that. If A is negative, we will be in the opposite quadrants. We will be up here, quadrant 2, and we will be down here in quadrant 4. So that gives you a general idea of what's happening with this. So let's kind of take a look at this stuff in action right here. Y equals 1, x minus 2 plus 3. So I can come through, I can draw a set of axes to graph this. And I'm going to say opposite same for my center. So opposite here, same here. 2, 3. 2, 3, that is my center, my locator point. Two, 3. I'm going to draw a set of asymptotes right through the center. My graph will never hit these asymptotes. It is impossible. There we go, 2 asymptotes. Now I need to take a look at my A value, which is right up here. A is 1, and it is positive. So I know I will be up here in this section and down here in this section as a little cheat sheet to myself. We are always going to be looking for the point on either side of this center of this locator. I guess not always, but for what we've been doing so far with parent graphs, yes. So if I slide over 1 to the right, A tells me how much to go up or down, and since I am in that quadrant, I know I will need to go up. I guess it's not a quadrant, but you get the idea, hopefully. If I slide 1 to the left to find the point on this side, A tells me now how much I go up or down, and I will need to go down. So I am in this zone. Now I can sketch my graph, make the turn, and if you want your graph to get more accurate, by all means, feel free to create an XY chart and plug in additional values. Sorry, that should have gone through the point right there. Now, from your locator, that gives you a lot of other information about this graph. From the locator, we can find our asymptotes. Our asymptotes, slide it up for you, there you go. We have an x equals and a y equals. My x equals will be my vertical asymptote, and the equation of this dashed line is x equals 2. That is an asymptote, and as you can see from my locator, x does equal 2. Come in here, the equation of this asymptote, my horizontal asymptote, the equation of this line will be y equals 3. And as you can see from the locator, y does equal 3. Those are the equations of our asymptotes. Now let's deal with domain and range. Domain is all the possible x values that are represented by this graph. So as we slide across, it keeps extending into that negative range, so we're always hitting it. Negative infinity, and we keep going, we're still hitting it, except right there. We lose our graph, and we cannot exist at the value of x equals 2. But then as you continue on, we are being represented by our graph, and all of those positive values are included to infinity. So it is all real numbers except for 1. That one real number that cannot exist, x cannot be 2. And it's the same idea for your range, working your way up. Excuse me, lost that there. As you slide up, you are hitting negative infinity, still hitting it, except for right there. And then I start to hit it again, all the way up to positive infinity. So it is all real numbers, except y cannot equal 3. So our asymptotes, the equation of our asymptotes, come from the x and the y value of our locator. Our domain and range is all real numbers except for the x value of the locator, x cannot be that, and the y value of my locator, y cannot be that. Asymptotes, as a little side note, they cannot exist. It is impossible to have an x value of 2. So if we take a look at our original equation, 1 over x minus 2 plus 3, if we substitute in an x value of 2, let's take a look at what happens. Y equals 1 over 0 plus 3, and hopefully you're seeing something terribly, terribly, terribly wrong with that. We cannot have a denominator of 0 that is undefined. That is why our graph is undefined at this x value of 2. Our function is undefined. We cannot exist. And same type of idea when we're dealing with this y equals 3. If I take 3 and I substitute it in for y in my original equation here, we get 3 equals 1 over x minus 2 plus 3. Now I'm looking at that and I'm saying, okay, that thing kind of makes sense to me. I can simplify it a little bit. I can take this whole 1 over x minus 2, and I can just use some common sense right there. 3 equals something plus 3. And if I think about that, the only thing that something could be is 0. 3 equals 0 plus 3, that would make it true. But if you remember what happened earlier, with this 1 over 0, I don't see a way that we can make 1 over x minus 2 equal to 0. Interesting. Therefore, y cannot be 3. Take a look at one more really quickly, and then you will be done with your rational parent graph. Y equals negative 3x, let's say minus, what did we do beforehand? Let's say minus 1 minus 2, just so it's not the same as what we dealt with. So first, let's get a big set of axes drawn. Locator point will be opposite same, so 1, negative 2. 1, negative 2. Right through your locator point, your center, you can draw our asymptotes. The equation of this asymptote is x equals 1. The equation of this asymptote would be y equals negative 2. You now have the equations of those asymptotes. You can fill them right in if there's an answer blank for that. Now I'm looking at this a value, and it is an a value of negative 3. So when I'm thinking negative, and conveniently for my Algebra 1 class earlier, I had a negative there on the left hand, and I had a positive there on the right hand, so that kind of works. It's negative, so I put the left hand up, and look where it lands me. I'm going to be here and here. So a little note to myself, that's where I'm going to be when I graph this thing. I'm going to be looking for the points on either side of the center. So if I shoot over to the left, a value tells me to go up or down this many. Well, I'm going to go up because I need to be in this area, so I will go up 3 for my first point. Same thing as I move over to the right, my a value tells me how many to go up or down. I will drop down 3. And there we go. Now I can come up, I can grab that point, and I can kind of start to make my turn. Remember, my graph will never hit either of those asymptotes, and it is the same thing coming down in here. As soon as I hit that point, I'm going to start making my turn. I'm sorry, that paper just bunched up on me, and that is a pretty ratty looking rational graph, but hopefully you're getting the idea. Asymptotes, x equals 1, y equals negative 2. Domain, all real numbers, except x cannot be the x value of my center. X cannot be this line right here. X cannot be 1. Range is all real numbers as well, except y cannot be the y value of my center. Y cannot be this line right here. Y cannot be negative 2. Thank you very much.